In this figure, we are required to find the area of this circle here. So we have a circle and then it is inside a square, okay? The circle touches all the points of the square and we have a small rectangle at this point where its width is 1 and its length is 2. So with that information, how can we find the area of the circle? First, let us draw a line vertical through the center, okay? And that touches these points of tangency. Just like this. So this line of the square is tangent to the circle. Also, this line of the square is tangent to the circle, and we've drawn this line. It is perpendicular to these lines here of tangency. Okay, let's call this center O. Let this be M and this point N. As we've already said, this is 90 degrees because of the tangent to circle theorem. The diameter is perpendicular to the tangent to the circle. Now, suppose MN is a line of reflection, okay? Then that implies that we would have something like this mirroring on this side, okay? So where this is 1 and this is 2. Sorry, it doesn't look proportional because, I should have drawn it from somewhere here. So if this was a line of reflection, then this would be mirrored to this side to give us this, okay? So we have, this is 1 and this is 2. Now, let me call this point P and let me call this point Q. Now, if I'm to connect point P to point Q, so we'd have something like this. If I connect them like that, then it means PQ would be intersecting with the diameter MN. And let me call this point of intersection R. So at the point where they intersect, this is 90 degrees. Now let's draw a horizontal line from point O to this point of tangency. So let me call this point T. So obviously this is 90 degrees because a radius tangent cutting a line of tangency makes an angle of 90 degrees. Now let us let the radius of the circle, let it be R. So if it's R, this will be R, also ON will be R, also OM will be R. Let me call this point U. So also, since this is T, O, which is R, and this line is parallel to this line, that implies that UR is also equals to the radius. But remember, UP is 2. Therefore, PR, this implies that PR will be equals to, from here to here is R, so this will be R minus 2. So PR is R minus 2. But remember, if we are to reflect, also RQ is R minus 2. And the diameter MN is R plus R, which is 2R. Now, since MR from here to here is 1 and OM is R, so OM is R and MR is 1. That implies that OR will be equals to R minus 1. So if OR or RO is R minus 1, that implies that RN will be equals to RO plus ON. So Rn will be equals to RO is OR, which is R minus 1, then plus ON, which is R. So this gives us, this becomes 2R minus 1. So implying that from here to here is 2R minus 1. Now, looking at line MN and the chord PQ, we know that from intersecting chords theorem, if you have this, and this is A, this is B, this is C, this is D, then AB is equals to CD. So that implies that in our diagram, our A is PR. So our A is PR, which is R minus 2. Our B is RQ, which is R minus 2. And our C is MR, which is 1. And our D is Rn, which we've got as 2R minus 1. So applying this here in this formula here, which is AB is equals to CD, we shall have R minus 2 into R minus 2 being equals to 1 into 2R minus 1. So when you open these two brackets, when you multiply, you will get R squared minus 2R minus 2R plus 4 being equals to 2R minus 1. So we have R squared, this becomes minus 4R plus 4 is equals to 2R minus 1. So we bring all this on this side. We have R squared minus 4R plus 4 minus 2R plus 1 is equals to 0. So we have R squared minus 4R minus 2R gives us minus 6R plus 4 plus 1 gives us plus 5. This is equals to 0. So now we have a quadratic equation which we're going to solve using the quadratic formula. So R will be equals to minus B plus or minus B squared minus 4AC over 2A. So R is equals to minus B is negative 6 plus or minus negative 6 squared minus 4 times 1 times C, which is 5, over 2 times 1. And so R is equals to 6 plus or minus, this is 36, minus 4 times 1 is 4, 4 times 5 is 20, over 2 times 1 is 2. R is equals to 6 plus or minus root 36 minus 20 is 16, over 2. And so R is equals to 6 plus or minus 4 over 2. So R is equals to either 6 plus 4 over 2 or 6 minus 4 over 2. This will be 10 over 2 or 2 over 2, which gives us 5 and here 1. But when you look at these two, when you consider R to be 1, here from PR is R minus 2. So if R is 1, it will be 1 minus 2, which will give us a negative 1. And that is impossible. We cannot have a negative distance. Therefore, we reject this and consider R is equals to 5. So now that we know that radius is 5, we can now find the area of the circle, which is pi r squared. Therefore, area is pi times 5 squared, which equals 25 pi. Okay, so this is the area of the circle in square units.